Hi, and welcome to my Simhangar. If you have hardware instruments and lights, you will need a way to read the data from the sim and control those instruments. This tutorial tries to show you how this can be done with BMSAIT. The first thing you need to do is to download the package from GitHub. Once you're on the page, just click the green code button and select the download zip file, and it will get downloaded to your drive. After opening the zip file, the first step is to extract the Windows app folder to the location you want to run the app from. In my case, I copied it to C programs BMSAIT, but of course you can copy it to wherever you like. In the directory Arduino code, you will find all the needed headers and files to program your Arduino. The two most important files are the userconfig.h and the .ino file, because those two are used in every instance of an Arduino. Here you can see the directory I used for my right auxiliary console. Make sure that the file name of the .ino file matches the directory name, because otherwise your Arduino IDE will not be able to program your Arduino with it. The other files in this directory are all those header files you use for specific hardware you want to control with that specific Arduino in BMSAIT. Now let's have a look at the two important files to program the Arduino. The .ino file is the main part, which runs all functions and controls the program itself. As long as you use the standard BMSAIT modules, you don't need to change anything in here. But if you want to add your own hardware to it, that's the place where you have to add the if-def things for your own hardware so it gets implemented in the compilation. The userconfig.h file is the place where you configure your specific Arduino to use with BMSAIT. The first section is the part where you tell BMSAIT what hardware to use in that Arduino. For example, if we want to use servo motors connected to our Arduino, we have to comment out this line, and it will include the code for controlling the servo motor in the .ino file. The basic settings is the part where you define communication between the Arduino and BMSAIT. So the important parts are the baud rate and also the name of your Arduino. Make sure to use BMSAIT underscore at the beginning of the name, otherwise BMSAIT will not recognize it. The board selection part does exactly what its name suggests. You just choose which kind of Arduino you're using, just like with the modules at the top. So since I'm using a Mega, I'm going to comment this line and remove the comment for this line, so it's going to be used with the Arduino Mega. For this video, I'm going to start with a completely fresh installation of the Arduino code, and we will try to add some servos to it and move them. So once the basic settings are done, I'll try to upload the code to the Arduino and see if it works. Make sure to select the right board in the tools menu and also the right COM port to write to. Once the Arduino program has been uploaded, it's time to configure the Windows program of BMSAIT. The first thing you want to change is to edit the basic settings. I already changed the language to English, but by default it is set to German. So the next thing to do is to locate the two files BMSAIT variablen.csv and the gaugetable.csv. Usually they should be in the directory where you installed the Windows program. Since we don't have a configuration yet, the default user configuration line can be empty and will be empty, and also the pilot.ini will not be filled out. The other things I think are very self-explanatory. With the basic settings done, it's time to add our first Arduino device to the configuration. To do this, we right-click on the root node, add device, and now we could either select the specific COM board we used and the baud rate, or we could click show all ports, select the baud rate we put in our user-config.h, and now with start, it will start to check all the COM ports and tell us on which board BMSAIT configured Arduino will be available. Now we know COM port 3 with 57600 is our board, and we give it a name, for example, demo Arduino. The data transfer method tells BMSAIT if it should push data to the Arduino or if the Arduino will pull the data by itself. I started to use push because in my experience it's a bit more stable. Since we now know that BMSAIT can talk to our Arduino, it's time to add the first hardware and the first variables to control it. In my case, I want to control two servo motors controlling hydraulic A and hydraulic B on the right auxiliary console. To do this, first I comment out the define servo motor, so the servos can be controlled. And the next step is to tell BMSAIT which data to use. This next step is the part working with Arduino where I always run into things I didn't see or recognize, so I try to give it a bit more attention right now. To tell BMSAIT which data from Falcon BMS to use, there are two places where we have to put this info. The first one is the variable Datenfeld inside of the Arduino code. The other place is the configuration inside the Windows program. The regular way to add data to the Windows program is to right-click the device, select Add Variable, and you will get the data variable selector with all available data from BMS, and at the end you will see variables coming from DCS also. But this list is quite long, and it's very hard to find something because you can't search in it, and you have to know where the data you're looking for is located. To make this easier, I always open the BMSAIT variablen.csv in the editor, because here I can search and find the things I'm looking for. For example, I'm sorry you can't see the search window inside Notepad, but if I search for HUD for hydraulic, I can scroll through my findings and can see where the variables are located. As you can see, hydraulic pressure A and B have two variables inside the list. One, the regular data out of Falcon with data type float, and the second, which is a great addition made by Hammer, is the pressure value from 0 to 65,535. So you don't need to do the calculation where to position the needle by yourself in the code. You just tell the Arduino the start and end position in degrees, and it will calculate the position based on this variable. That's why I like to use those variables in my code. Since we found the numbers 281 and 291 in the variables file, it's now much easier to scroll to 281, select hydraulic pressure A, apply, add variable, go to 291 and select hydraulic pressure B. Now we have the data configured in the Windows section. What's left to do is to do the same in the userconfig.h. There are two sample variables set here, which I'm going to delete, or let's keep it in there, add some fresh lines, and copy it Now we have to change all those fields to match our variables we've configured in the Windows program. The first field, description, is free to use, but it has a max length of 5 digits or characters. Let's call it HUD A, and the second one HUD B. The second field is it's called ID, and it's the variable we've used here. The same number we have to use here, so we have to use 281 and 291 for hydraulic A and B. And you have to use a leading 0 if the number is lower than 1000, or 2 leading zeros for numbers lower than 100. So it's 281 for hydraulic A and 291 for hydraulic B. The third field, is the data type. In our case, those both are integer numbers, so data type for both is I. And finally, the output type should be a number representing one of those up here, or since not all of those are documented in here, you can have a look at the .ino file. Scroll down, and there somewhere is, yeah, in the update output function, you can see what number corresponds with which hardware. In our case, we are using the regular servo, and servo motors, which is also documented here, is 40 as output type for servo motors. So we'll change 12 to 40. Now we can delete our default lines. And if we try to upload it, let's save here. And let's go to our Arduino IDE and upload the file, or let's compile it first. We get an error message. You can't see it here. Let's scroll up here. It says it doesn't find the servo.h file. When we look in our Arduino code directory, only two files are there, the userconfig.h and the .ino file. So we need the servo header file in here so the program will compile. We can copy it from the Arduino code directory. Let's see, here's the servo. Control C. Go back to our demo file, Control V, and let's open it in our editor. The servo header file includes all the code to control servo motors connected to one pin on an Arduino. We've got a struct here that shows us data for one motor. We have the pin the motor is connected, the lower arc for the motor, the upper arc, and lower and higher values to map those two positions to. So we can add more than one motor here. If we just copy this line, now we have two servos in here. And to tell BMSAIT which data is controlled by which motor, the target reference in the userconfig.h is used. We've got an array here called servo data with servo at position 0 and a servo at position 1 in the array. And those are the two target numbers we have to edit here in the target field in the userconfig.h. Now I'm going to configure my two motors with the values of my hardware. My first motor is connected to pin 40. The second one to pin 41. Through trial and error with a test program, I found that the lower position of 3 degrees is position 0 for the first instrument and 12 for the second. 157 is the high position for the first motor and 168 the position for the second motor. All the other values we can keep as they are. Let's save this. And now let's see if the program compiles in our Arduino IDE. Okay, we get another error. And that's one of the things where it's really okay if you can debug some code, because the message is the servo class doesn't have a function or attribute.lu, which is correct because it's servo data lauf, which has this attribute. Let's save it again and try again to compile. Now everything is okay, and the configuration for the first motor is done. Since the program compiled without errors, now it's time to upload the program to the Arduino, and let's see if the setup function does the first demo run of the motors. Not bad, but not what we wanted. I wanted the two servos to move to the high, middle and low position, but when I had a look at the code, it stopped in the middle position. So now I'm going to add the low position again in the end, and also shorten the delay to 500. Save. Compile again, and let's see how it does. That's more to my liking. Before we are going to test this configuration with BMS, it's always good to save the ini file. That's my regular file. We call this demo.ini. So we don't lose anything in case BMS or the PC crashes. I found a small bug in the servo header file because the 5-second delay to detach the servos is a bit too small, and the servos won't update from BMS, so I set this to 20 seconds, save it and upload it, and that works better with servos. Now it's time to see if our configuration also works with BMS. I already loaded one of those TEs, free flight or navigation or landing, where you start in the air already. So I don't have to go through the whole startup routine and have all engines running and all systems go. I also put Falcon into freeze mode, so I don't accidentally run into the ground while testing. And since we've configured everything as we wanted, now we just click commit and see if BMS and BMSAIT can communicate. Now the Arduino did the reboot, and as you can see, the hydraulic pressure indicators are quite there where they should be, more or less. Looks good so far. Not everything goes as planned with BMSAIT. As you can see, even the demo code made by Hammer is not without some bugs in it, and those will occur. It's not a question of if, but when those bugs will occur, even in your own code. So one thing that's built into is the readback of the Arduino to BMSAIT. If you set readback mode to true, save and upload the file again to the Arduino, you will, and I'm not sure if you have to enable debug mode, but I always during testing keep it on. Once you start BMSAIT and it connects to BMS, you will see which variable and which value is sent from the Windows application to the Arduino. That really helps if you're not sure if those values fit to the needle positions or displays you are having. One other thing you can do is to enable the global variable debug mode and set it to true. This way you can use the send message command inside your Arduino code to see if everything is working. For example, if we want to see if our update server routine gets called, I can implement a send message update called here. And since we have a global variable, we can do an if debug mode. So this will only work if debug mode is enabled inside our Arduino code, not inside the Windows application. If we upload it now, and connect to BMS, you can see it gets called. Clicked too often. And that's a good way to see which data gets sent from BMS through the call. It's called the readback mode. And the second one is with the send message command inside your Arduino code. You can see inside the Windows application messages or data inside your Arduino, which you can't see otherwise because you can't connect to the serial board on the Arduino with a terminal because it's blocked due to communication between BMSAIT and the Arduino. Another trick to work with BMSAIT and make it a bit easier is to edit the ini file inside an editor. For example, our demo init looks like this at the moment. And as you can see, each variable number is listed here with the index behind it. So for example, if I want to add, let's call oil pressure, it's 3201. So we can copy that line, set 321 and the index is 2, save. And if we reload our ini now, the oil pressure variable is here. Don't forget to add it to your Datenfeld variable, of course, in the Arduino if you want to use it. But this way it's much easier to add more variables to the Windows application, since clicking add variable, have a look for the variable, click apply, add another one, is quite tedious. And with this method you can add a lot of variables very fast to the ini file. Always make sure that the index in this column fits, because otherwise you could run into problems. Adding additional functionality to the system is quite easy. First, you have to select which module you want to add. For example, if we want to add the DED, we just uncomment this line. And then, of course, we have to select the variables which give us the DED data, which I've already done here at the end of the file. To stop getting compilation errors, you of course need the corresponding files like the header file or the font file inside your folder. Finally, of course, we need the same variables in the windows.ini. So we could either use the add variable or edit the ini file itself. Don't forget to change the index here. Now if we save it and load it again here, the variables are there, and they should also be the same order in the header file. This way you can add any module you like to a given configuration. Just make sure that your Arduino is capable of handling all the additional tasks. So the regular debugging steps should always be: first, see if the regular setup functions of your hardware is called and the hardware does what it's supposed to do. This way you can make sure that the hardware connections inside the Arduino, all the connection to the motors, is okay. If this works without problems, the next step, if it doesn't work with BMSAIT, the first step is always to check if your Datenfeld variable and your configuration inside the Windows application are the same. I think my guess would be 89 to 90% of all those errors where you don't get the data out of BMS into the Arduino is because problem between this configuration and the configuration inside the Windows application. If those two look okay, then you can always enable readback mode, debug mode, and send messages from inside the Arduino code to the console inside BMSAIT to see if values get sent to the motors or your hardware as it is intended, or if there's a problem in communication, for example, between the INO file and the header files. I hope this little tutorial will help some of you to drive your Arduino instruments with BMSAIT. Once you understand the basic concepts, it's not too hard to use and you can do amazing things with it. Thanks for watching.